This is a miniature version of the new ion drive which I've built, which might be useful, say, for satellites. We just have one ring magnet, say 60 millimeter with a 20 millimeter hole, two little tubes of copper. We'll put some argon gas between the two tubes. You can hear it hissing. And now we're going to turn on about 4 kilovolt of DC power and see what happens. You can see the gas is shooting out and jumping toward the magnet quite strongly. And you can feel a lot of hot air coming out here on the end. Just turn up the power a bit. You can just remove the satellite. Let's turn up the gas a bit. A really strong stream of hot air coming out that way. Hot air is just pouring out here like a fan motor hitting it. My hand's going to burn in a second. I've got to move my hand because it's going to burn. Do you think this little jet engine would be suitable for satellites? I do. Let's show you now how it works. Let's show you now schematically how this device works. We have a ring magnet and two copper tubes, one attached to the red wire and another to the black wire, of 4 kilovolt DC power supply. So here's your magnet here with a ring magnet with a hole in the middle. There's the copper tube which fits inside of it. And inside that's another tube which fits inside both of them. And now when we put that copper tube almost in the center of the ring magnet, so the ends are matching, the gas will spin very well, but it only gets warm. It doesn't do much else. What we really want to do is to position these copper tubes very carefully, about 5 to 10 millimeters outside of this hole of the ring magnet. When we do that, the argon gas will ionize, and it'll then jump forward through the hole in the ring magnet like thrust. It'll get very, very hot. So you see we've got minus inside, plus outside. The gas comes in from a power supply, it ionizes here, then that little capacitor just jumps forward to the hole in the ring magnet and shoots out its very hot thrust, which will burn your hand when you put it on the other side. And that's what I just showed you. Now, how did I get the idea how to make this clever device? Did I think of it in my head? No. I saw it in a crop picture from the Czech Republic in 2018. There you can see a magnet like we have here, and we have two tubes, one on the inside, one on the outside, and current flowing in between them and spinning as it goes under the influence of the magnet. And at a certain location of the magnet relative to the copper tubes, it will not only spin, but shoot up and emit hot gas below as thrust. This is a little miniature version of the ion drive which I made, say, for satellites. Let's turn on the power and see how it works. Lots of hot air is just flowing out of there. It's like an ion jet engine. Now that everything's cooled off, I burned my hands quite a lot because it got so hot. I'm going to show you how this very simple device works. First, you need two pieces of copper. For example, I've got this thin rod in the center and a little tube outside, and we'll put the two ends of the tube together about there. And the trick here is we have to have the inner tube sit in the middle of the outer tube without touching the outer tube anywhere for electrical reasons. That's a little bit fussy, but you can do it. The next thing we have to do is apply electrical charges of 4 kilovolt DC, red and black, to these two tubes. Typically, the red wire positive will go to this big thick outer copper tube, and the black wire negative will go to the really thin one in the center. Next, we need a ring magnet. For example, this neodymium N52 ring magnet with it, which is 60 millimeters in diameter and 20 millimeter hole, and we'll put those two copper tubes inside the center of the empty hole. They have to fit inside with a little insulation between the two so you won't get electrocuted. Next, we have to position the magnet accurately relative to the two tubes. If we put the magnet way out here or on the other side, the gas might spin, but it doesn't do anything else. The tube doesn't get very hot. When we put that magnet not far from the ends of those two tubes, then, as I'll show you in a minute, the ionized argon gas jumps out like a rocket flame, and you have to adjust that very carefully. So there are two things you have to adjust to make this to work. One is where the magnet is relative to the inner electrodes of these tubes. And the second thing, you have to make sure these tubes don't touch one another anywhere. There have to be some space between them or else they'll short circuit. The device won't run on air, so we have to get a cylinder of argon gas, often used for welding, from a local hardware store, run a little tube out of it, and put the argon gas so it flows outside of the little copper tube but inside of the big one, and when it flows out there in the presence of DC electricity, it will ionize to argon cations on the inside, electrons on the outside. Finally, if we add a magnet just to the front, those argon cations will shoot out very strongly to the left with a lot of heat, as I'll show you diagrammatically in a minute. Power supplies, which I'm using to get 4.4 kilovolt DC, are just an isolation transformer of 1,000 watts, very essential not to electrocute yourself. A variac which runs at 1,000 watts for the 240 volts. We have a run capacitor of 60 microfarads to limit how much current goes at 1,000 watts into this two microwave oven transformers which are wired in series, and that gives you 4,400 volts AC. I put it through a little rectifier which is rated to 6 kilovolts and 3 amps, and that converts the yellow AC to red and blue DC, and then those wires come over here to one copper tube or the other copper tube to get a big DC voltage between them. So just as a detail, I find it useful to put some capacitors, these are all 2 kilovolt each and 1.8 nanofarad each, between the red and black wires just to maintain a constant DC voltage coming out of that rectifier. The net capacitance here is only 0.4 nanofarad. You don't want to go any higher, but that makes the DC voltage coming into the device a little more stable. Final note, when you work with microwave oven transformers, I have two of them in series here to give 4,400 volts. You always have to put a plastic box around them because they're live to the touch and will electrocute you if you accidentally touch them in any other way. Also, you have to use a run capacitor like this to control how much current goes through it, basically like a resistor for AC. That's 60 microfarad, and you have to use an isolation transformer that's 1,000 watts. So when you use a wall supply, it's not live to ground. With those three caveats, this device is fairly safe to build for an experienced person.